Hello friends, welcome to session 5 on orthographic projections where we are doing some of the components related to machine objects. That is, they are called as machine components in mechanical engineering. We are drawing the isometric view of the machine components will be given. You are supposed to draw the orthographic projections of the machine components given three-dimensionally. Okay. See here, machine component 2. Okay. This is how a simple machine component. Okay. So many times this type of problem will be given to you in the exam. See here, this is the direction of front view. You have to take care of the dimensions. And also you have to take care of the arrow. In which direction they want the front view, that has to be written. If you take this direction as the front view will be different. If you take this as the direction of front view will be different. And you get totally different answers. But in the exam, be careful which is the direction of front view you observe. If this is the direction of front view, you have to draw as per this direction only. Front view, top view, and as you see here, in isometric, the principle is left surface is seen, right surface is seen, top surface is seen. In that way, front view, top view, since right surface is seen, since predominantly right surface, right view should also be written on left profile plane. That's what I did. Right view, front view, top view, right view. Okay. Now I have given for this object, I have given the dimensions here. 150, all dimensions are there. In case any dimension is missing, you can assume the dimension and clearly you can state it in your answer sheets that this is the dimension what I've assumed. Here I think all the dimensions are there. Now as you see here, looking at that, this is direction of front view. This front view has to be drawn. Top view has to be drawn. Since right view is there, okay, right view is predominantly seen. Right view should be on left profile plane. That is why you make xy, x1, y1, vp for front view, hp for top view, lpp for right view, which is on left profile plane. Okay. Make vp, hp, lpp, xy, x1, y1, make it ready. This is the first stage. Okay. Now, as you see here, your direction of vision is this front view. Okay. Your direction of vision is front view this way. When your direction of vision is front view this way, you imagine vertical plane just behind this. That means your vertical plane will be just behind this and your direction of vision will be perpendicular to vertical plane. As a result, this entire surface will be seen in its true shape in the front view. And even this and all that you should see the true shape in the front. Okay. First we'll concentrate on writing the front view itself. Now you draw. See here, this is 100. Draw this 100 dark. Okay. And this you draw 40 because the 40 they are given. 40, you draw 40 here. Okay. Then you see it is a diameter of 40, radius 20. That is, you draw one line from this, you get the center here. 120 radius you draw here so that this distance should be 40. Okay. This distance should be 40. Then come down. And as you know, this distance is 10 mm. This is 10 mm. In that way, you are completing this. Okay. This is diameter, that is radius 40 semicircle, radius 20, diameter 40 semicircle. This is 40. This is totally 100 as you see here. Okay, 100. And this thickness is 10. That I have written 10 here. Okay, I think you can see 10. You draw this. Okay, this is the thing. Now, if you draw this, there is one, when you're looking from here, there is one circle also here. Circle is of a diameter 20. That means radius 10. Concentric to this semicircle. Okay. This center and this center should be same. Concentrically, you draw a circle of radius 10 or diameter 20 here. In that way, more or less, the front view is completed, except for this portion. This portion is called the rib portion, what you normally call. They are the supporting structures for machine components. I'll come to that later on. Okay. Now, this rib has to be drawn. Now, when you're looking from here, this rib surface, since the VP is behind this rib surface will be perpendicular to VP. That means this surface will be seen as a line, inclined line in the front view. Okay, that is why this rib surface is seen as a line in the front view. You draw a line here. Okay, that means how to draw a line is from this corner, draw a line tangential to this semicircle. Okay, tangential to this semicircle. The point of tangency you call it as T dash. That means the front view is completed in all respect. You have drawn this, okay, you have drawn this, you have drawn a circle, you have drawn the rib also in the front view. How you have drawn the rib is, draw a line tangential to this semicircle. Wherever is the point of tangency, you stop it and call it as T dash. Okay, call that as T dash. Okay. Now that is this is the point T, point of tangency. Okay. Then once you do this, you write the corresponding top view. When you write the corresponding top view, you take this distance, any distance. Whatever is this distance, you make the same distance, preferably here also. Okay, you leave some distance. And as you know here, the top view, if you draw, this distance is 50. That is, since VP is just behind this, this is the distance in front of VP. With reference to this corner, this distance is 50. That is, with reference to this corner, this distance is 50. Okay, this anyway is 100. You are taking the projectors from here only. Take the projectors and take 50 here. In that way, you complete this rectangle. Okay, once you complete the rectangle, you please observe the rib has to be drawn. Rib in the top view, the rib has a thickness of 10 mm, correct? No, 10. Okay, this 10 mm thickness you draw here. But the rib has to be drawn till what point will be the question. But be careful, don't go on, you can't go on extending. T dash, the rib point, that is point of tangency in the front view, you know. Okay, the T dash. From there you draw a projector, a red line I have shown, a red arrow. You show that this rib in the top view, this is thickness 10. Okay, thickness 10. For thickness 10, you go on drawing till you meet this projector. That means this is the point of tangency in the top view. That means the rib you show up till here. Okay. That means, did you follow? This is 100. You take any distance here. This is 100. This is 50. And this is 10. And the point of tangency is this. That is 10 mm you take here. Up till here you take this. Okay. Up till. That means the top view is completed. And you see here, there is a circle also here of diameter 20. This is 20, which you cannot see in the top view. That will be seen as dot dotted in the top view. That is why you show dot dotted here, dot dotted here. That means from this, from here only you draw a projector. See here, I'll draw a projector here. Show arrow down, show arrow down. In that way, a projector. From after this point, show dotted line, clearly representing when you are looking from the top, this object, this pole cannot be seen by the observer. Okay, this pole cannot be seen by the observer. That's why you have drawn this as dotted line, this as dotted line. Okay, front view is completed, top view is completed, even rib also we have completed. That means the rib here is the point of tangency. From this you complete, you come down, and this has a thickness of 10. You go till you meet T dash, the projector from T dash, and you call it as T. That means front view, top view has been completed. Then you have to concentrate on this right view, which is on left profile plane. And left profile plane you have to draw. You draw this. When you do it here, you know very well, this distance is 50. Correct? Now, when you are looking from here, this distance you take 50. 50. Height you take the projectors from here only. That means the height is 60 anyway, you know, this is 40 plus 20, height 60. In that way, 50 by 60 rectangle you draw. This is a projector from here. This height you don't have to worry because it's just a projector from here. But the width here is, as you see here, when you're looking from here, that is from right view, this distance is parallel to, this surface is parallel to the left profile plane. The same area should be seen in, since it is parallel to left profile plane, the true surface should be seen. That is what is this area. Okay. In that way, this is 50, this is 50, and this is 10. You can take the projector from only, this is 10. Okay. Once you do this, see here, you have to show the, again, when you're looking from here, this rib has to be shown. A rib it has a thickness of 10 mm. Take a 10 mm. You can't go on doing this way. But carefully you see, the point of tangency is T dash here. From there you take a projector here. Okay. Then you take the rib. Okay, 10 mm thickness rib. And you stop at T double dash. Okay, this is T dash. Stop at T double dash. In that way, the front view is completed. Okay, the front view is, right view on left profile plane is completed, except for the fold. Fold also, this is a fold of diameter 20, correct now? That cannot be seen in the side view, that is right view also, which we are doing it on left profile plane. That is why even this also you make it dotted. Okay, in that way, if you do the front view, do the top view, do the right view on left profile plane, show all the dimensions here exactly in this way, take the printout. Okay, if you take the printout, you will have all the dimensions, all the, that is front view obtained, top view obtained, the right view and left profile plane obtained, and all that. You are not likely to lose any mass. Okay, this is how you complete the projection. This machine component 3, let us say it is this. Okay, when it is this way, okay, here it is a front view because direction of front view predominantly seen is right. That is why again right view on left profile plane has to be drawn. Okay, now you see here this also, take care please. Okay, now as you see here, when you are looking from front view here, VP, imagine this to be behind this, parallel to this surface. Okay, or the direction of vision is perpendicular to VP. In that way, as you can see here, this height is 20. Can you see this? 20. And as you see, this is 70. This is 14. This is 14. That means this is 14. This is 14. Okay, and in between 70 plus 28, 98 is the total distance. Then height is 20. You can see this height as 20. Your height is 20, you draw. And this distance is 14 I have given here. This distance is 14. In that way, you complete the front view this way. And this distance also I have given here. This depth, this height, no, this undercut you have, that has a height of 6 mm. That also you take 6 mm. 6 mm, that means this entire thing will be seen as true surface in the front view. Along with this you take. This total distance, as you know, why it is 62 is, this is 20 plus 21, okay, 41, plus another radius, 542, that is diameter 42, plus radius 21. 21 plus 21, 42 plus 20, 62. 62 is the height, and this is 14, what I have given here. In that way, the front view is completed. Once you complete the front view, you have the two folds and all that. You immediately complete the top view. You take any distance here. This distance you preferably take here also. Okay, you take the projectors here, and as you are looking from the top, this is 42. 42 you take. Okay, anyway you are taken from this only. The same thing, 70 plus 14 plus 14 is 98. Okay, that distance will be here. Okay, in that way top view is completed. This edge cannot be seen in the top view, make it dotted. This edge cannot be seen in the top view, that is this edge and this edge cannot be seen in the top view. That is why make it dotted. Okay, and also right fold, that is fold is 24 from here. If you see here, it is this fold is 24 from this edge and 24 from this. In that way, draw circle of diameter 24 here, 24 here, 24 here, and diameter is 12. 12 mm circle, 12 mm circle you draw here. Okay. Once you draw 12 mm circle, 12 mm circle here, this at the center, no, 42, 21 only you take. Okay. Once you draw, from here the distance is 24, from here the distance is 24. Okay. Once you do this, corresponding front view draw. Front view, you can't see the pole in the front view. Make it dotted. Make it dotted. Okay. Even this circle also is a 21 pole that cannot be seen in the front view, make it dotted. Okay, once you do this, front view is completed, top view is completed, the right side view you see, this entire thing, right side view on left profile plane, this you draw, this is true surface, anyway you can draw this, okay. After that, this is true surface, you draw the entire thing, this circle also you draw, okay. And as you see here, when you are looking from here, this fold cannot be seen, that is why make it dotted up till here. Even this edge cannot be seen. Okay, this edge cannot be seen. Make it dotted here. In that way, you are able to complete the top view, the front view, top view, and right view. Right view on left profile plane. Okay, you show that on XY, X1, Y1, VP, HP, LPP, right front view, top view, and right view, and all that you do. In that way, you are completing this session. We'll continue in the next session. Thank you very